Today, we want to find a solution to this quadratic inequality. So it's not equal to 0. It's either greater than 0, or less than 0, or greater or equal to 0, or less or equal to a 0. So the way we uh, find a solution to this inequality, as you can see, there are many solutions that make this equation greater than 0. So you're not going to have just one or two. Okay, so you're going to have an interval of the x solution to the equations. So the first thing that we want to do is to solve this and to get the solution to this. So instead of greater than 0, first we're going to solve this quadratic equations by making this equation equal to 0. So we can use the general formula to solve for x, or if you recognize it, you can factor this as x plus was that plus 3 and x plus 3 equal to 0. So where is that number 3 came from? Because 3 times 3, okay, to recall, 3 times 3 is 9, and 3 plus 3 is equal to 6. So that's where the 3 came from. So because these two groups, these two factors have the same solutions, x equal to -3. Okay. So now we're going to use the number line to show the interval of solutions to this inequality. So I'm going to draw the number line, just a straight line. And I just want to have that solutions on the number line. So let's put -3s on here. Okay, and of course, this is going to positive, and of course this end is the negative infinity. So we want to test this inequality by picking the number that is on the left hand of a -3 and the numbers on the right hand of a -3. So the way we pick in the number is pick the easiest number, the smallest number that you can find. But we want to test it out by just using the number that we pick and then plug in for the x to find the values of the equations. So for example, I test it out. Okay, so this is when I test it out. So I'm going to pick the number that's on the left hand of -3. So let's say I pick x equal to a -4. So you want to pick like more like a whole number. You don't want to put a decimal. You don't want to pick a fraction or anything like that. But you want to pick the last number. You want to pick the smallest numbers you can. But of course, they have to be on the left-hand side of -3, which is you can pick -2, 4, -5, and -6. But of course, it's getting larger, and which you don't want. So we want to test it out with x equal -4. Then we're going to plug the -4 into the equations, okay, into the original equations to see what it is. Okay, so I replace every single x with -4. And what I get from here? So I'm going to get 16 minus 24 plus 9. So what I have here is 1. So is 1 greater than 0? Yes, that's what we want. Okay, so we found the interval. And of course, the -3 divide the number line by two different regions. One is on the left-hand side. So this is the left hand we're talking about. Okay, and this is on the right hand. So we also want to pick the number that's on the right hand side of a -3. So let's pick the easiest one. You can pick -2, -1, but I think its easiest number would be 0. Okay, as long as you pick the number that not the solution of the equation, but it's on the right hand side of that -3. I can pick 1, I can pick 2, but the 0 is the easiest one. So I plug in the 0 to the original equation. Okay, so every time you time with the 0, it turns into a 0. Now we only have 9. 9 greater than 0. As you can see, it doesn't matter what the number is on the number line. When I test it out, they always greater than 0. But what do we want? The original equation question asking what are the solution and write it in interval. So it doesn't matter what the x is, they always going to be greater than 0. I prove it to you. So the interval will be from -infinity to +infinity. Now, but we have to take away the -3. Okay, so if I want to write it in terms of the interval, I don't want you to confuse you with the notations. Uh, there's notations. Okay, -3. So we take away -3. So let's write it. Okay, let's write it in terms of two different notate two different interval. We get to -3, and then from -3 to +infinity. Why we have to take away that -3? Because if x equal -3, this equal the original equation equal to 0, but the question asking for greater than 0, not equal to 0. Okay, all right. Now using decimals, and you can see when I graph this, and what happened when I put greater than 0. Look at the decimals. They highlight the entire thing, but you don't see the the graph of this because you see a straight line. It doesn't, look right. Okay, so the best way is kind of just write the equation and you find the solution, the graph of it, which is a parabola, but every part of this graph is above the x-axis. So when the graph is above the x-axis, it's greater than 0. So it's greater than 0 when x lesser than -3, and the graph is above, which is greater than 0 when it's greater than -3. Because at -3, this graph equal to 0, which we do not want. Okay. All right, move on to the next questions. Okay, now we have this equation that greater or equal to 0. So we have learned many ways to find the x. So for this one, I always try to factor it first to see if it's work. So thinking about two numbers time to get -8, and when you add, you get -2. You find it? Okay, so we can find those two numbers. Okay, so two numbers time, let me write it down, equal to -8, and when you add, it's equal to -2. So you're looking around, see what the factor of 8. So 1, 8, 2, 4. 2, 4 seem like it. So what happened is you pick -4 and 2. So -4 times 2 is 8, -8. Okay, and negative 4 plus 2, negative 2. So this is good. So now we need to write this in the factor of this quadratic equation. Now, as I mentioned before, we want to set this equal to 0, and then we want to solve for x. So for this one, we have two factors, we have two groups. So we need to solve for x from those two groups. So x minus 4 equal to 0, and we have x minus 2 equal to 0. No, it's positive 2 from here. Okay, make so now x equal to 4 and x equal to a negative 2. So now we're going to use the number line. I just want to put that solution on the number line. So that's positive infinity. This end is negative infinity. Now you have to put the numbers in order which was on the number line. So you have a solution x equal to 4 and x equal to negative 2. Negative 2 is smaller than positive 4. So from left to right, negative 2 need to go on the number line first, and you just put 4 someplace else. You cannot put 4 on the left and negative 2 to the right, because it just doesn't make sense that the smaller numbers on the right hand of the larger number. Okay, now we're going to test it out. Okay, now come to a testing steps. So we testing it out. Okay, so now on the left hand side of a negative 2, let's pick a negative 3. So we can pick negative 3. Okay, what about between negative 2 and 4? We can pick x equal to 0. Okay, so this is left, this is in between, and this is on the right. Okay, so in between negative 2 and 4, I pick a 0. What about on the right of 4? I can pick x equal to 5. So now I'm going to plug in x equal negative 3 into the original equations. I have negative 3 squared minus 2 times negative 3 minus 8. So now let's time all of this out. So this is 9. Negative 2 times negative 3, positive 6, negative 8. This is going to be positive 7. So 7 greater than 0. And now what happened when x equal to 0? I plug the zeros into my original equation. Is equal to negative 8. What happened here is when you have negative 8, it is less than 0. What about x equal to 5? You put 5 squared minus 2 times 5 minus 8. So 5 squared 25 minus 10 is in the middle minus 8 is equal to 7. No, 25 minus negative 18, 7 was greater than 0. All right, so now we want to put the sign on each of the intervals. So between 0, between negative 2 and 4, we have a negative. Okay. All right. On the left hand side of negative 2, which is negative 3, this is positive and this is positive. And we want greater or equal to a 0 right here. Make sure when you write the interval, make sure you switch the parenthesis bracket into the square bracket. So now let's write this. So let's write the answers in terms of interval. We want this and we want that, not the middle. So we want to write negative infinity, negative 3. I always use parentheses on the infinity, but because we also want this to be equal to 0, so we use a square bracket. And also we want the right hand side, so start from 4 square bracket to positive infinity. So the square bracket, okay, this square bracket, this is what we call the square bracket. Square bracket means equal. So now if using decimals, that's what we got. So you can see if I put inequality inside the decimals, what happened? It shaped the left hand side. What is solution here? This is -2. X equal -2. Oh, and then I make a little mistake. Say yes. I used in -3. So it's supposed to be -2 here. Okay. Because I'm testing it out, but the answer is supposed to be -2 and a 4. Okay, so I make a little typo there. Okay, and one on this side is 4. So anything that either x greater than 4 to the right hand side of 4, the solution to the inequality, anything on the left hand side of a -2, the solution to this inequality. And of course, we don't see the parabola. Okay, you want to see the parabola and you want to see the interval, you have to take away this greater sign of greater 0. So now we can see -2 here and a 4. Those two are solution to the equations x squared minus 2x minus 8. Any part of the graph above the x-axis, positive, greater than 0. Any part that smaller or below the x-axis is smaller than 0. And you can see from here, from -2, and the left-hand side of -2, look at the graph, it's above the x-axis. And anything on the right-hand side of a 4 is above the x-axis. And from between -2 and 4, what happened to this little small u? It's below the x-axis, less than 0. But the question one needs to be above or greater than 0. So that's why we have to choose the interval on the left-hand side of -2 and the right-hand side of 4. So if you put the inequality onto decimals, it does not show you the graph. It just shows you the shape of the solutions, but it does not show you the actual graph because the quadratic equation needs to have it in a U shape. So there's a lot of application you don't want to put the greater or um, inequality symbol onto the decimals. Moving on to the next one. So here I have 3x squared minus 4x minus 7 less than 0. So now we need to find a solution to this. So we can use, we can factor this if we want to, or you can use just decimals for this problem because I already showed you how to do it. So let's use decimals for this. So I'm going to put 3x squared minus 4x minus 7. So this is the parabola. I don't like to use the inequality symbol. I want to figure it out myself. So what are the two solutions here? One is -1 and one is 2.3. So the solution is x equal -1 and x equal 2.3. Then I'm going to draw the number line. Now between -1 and 2.3, -1 smaller and 2.3, let's just say that is over here. Now I'm going to test this out. So let's test this out. So I have left hand, I have in the middle, so in between, and I have right hand. So we can test it out by pick. So we can pick x equal to -2, or you can pick x equal to 0, or you can pick x equal to +3. So you can do that on your own, just like the previous example, but based on this graph. What is the solution? Is 1 less or equal to 0? What does that mean? Mean below the x-axis. And you need to include the solutions. So my answer would be, so again, you have to find the interval here, but because I just did it in the previous example for this problem, I just want to use decimals only. Okay, so the answer will be any part on the graph below the x-axis. So I can write down, because I also need to be equal to 0, I'm going to use a square bracket, -1, 2.3, 3, and then close bracket.